Alright, recording's rolling. It's Wednesday, December 3rd. Right, so you guys in front of me, second period. I know yesterday was a weird day. Most of you guys were taking the FAP test. Right, so on Monday I covered 6.4 and 6.5 with you guys. Yesterday afternoon I covered 6.6 with my other classes, and I'll do it with you guys today. So pretty much the same lesson as is already uploaded to Google Classroom, just for context. Okay, just go through those. Right, and then yeah, I'll walk around the rest of the class today because this will only take, I mean, 5 or 10 minutes at the most. And I'm happy to answer any questions that you guys have, help you guys out. Otherwise, today is mostly an hour to say. Tomorrow, I'll do a complete review with you guys on Module 6, which this review tomorrow is going to look a lot like your guys' quiz on Friday. And this will be the last quiz of the semester. Next week, we'll do midterm reviews. So you guys know what the agenda we're doing. Okay, so 6. Last. Oh, yeah.
Will you print out the guide for us or print it out at home?
Yeah, I'll print out the study guide. Actually, it's back there if you want it super early. Yeah, the study guide is on Google Classroom. I have printed them out. I do have a stock of them over here. And then next week I was going to go to you guys anyway. Okay, so if you wanted to see the midterm review early, okay. So Google Classroom for you guys. We can have a hard copy if you want it. Okay, so 6.6, solving radical equations. Actually, I don't think there's anything incredibly new in this section that maybe wouldn't have learned already in Algebra 1. Okay, so I'll go over a few examples with you guys. I think 3 key examples, and then from there, I think I could mostly get these. Of course, I have a longer full video if you want to see many, many more examples. So, let's start with this one. And so example 1. Okay, so solving radical equations. Radical just means there's some kind of root. It might be a square root or a cube root. You're mostly focuses on. Okay? And solving means, well, maybe you're solving for x. Okay? So how can you solve for x? Okay, so let's go through all the steps. What's the first algebra step? Yeah, subtract 2. Subtract 2. And do that on both sides, of course. Balance the equation. Okay? And now it's going to look like this. I wrote this pinky. Guys, what's the next step?
Square root.
Yeah, square both sides. Because on the left side, that undoes the square root. It's a wash. And on the right side, well, you need to balance that. So now it looks like that. Is that okay? Okay. You guys see step by step. Okay, so we're going step by step. We're trying to get to the last step and say x equals something.
Add 5.
What's it? Yeah, add 5. Add 5. Okay, now let's like that. Divide by 3. Yeah. And then that's the answer. Right, just like that. That's right. Okay. Now, a good thing to do too, especially if a square root is involved, is take your final answer, 7 in this case, and plug it back into the original statement and make sure it works. I mean, it should, but there are some exceptions. So let's try this out. If you plug in 7 here, guys, what's 7 times 3? 21 minus 5 is 16. What's the square root of 16? 4 plus 2 is 6. Okay, so this one worked out. That made it a true statement. So you can always check to work that way. Okay? Now, when a square root is involved, sometimes it's related to the fact that you're not allowed to take the square root of a negative number. You might end up with an extraneous solution. Actually, maybe I'll do one of those with you guys too. See if I can find one. Okay. But here, let me do a cube root with you guys, and then I'll do a couple of examples after this. Let's do a cube root. Okay, so again, we're solving for x. What's the first algebra step? How about add 9 to both sides? Add 9. Yeah. Okay. And now you want to do what? Yeah, divide by 4. Over 4 over 4. Okay. And now, well, you see the next step is to cube both sides. Right. To undo this cube root. Oh, actually, I think your book may have written this as a cube root. I wrote it as a power 1/3. That is a cube root, isn't it? Power 1/3. Okay. And you can undo that by cubing it. Balance the equation on both sides. Okay. Now let's take that. Next step.
-6.
Yeah, -6. And finally, last step is divide by 2. And the answer in this case is 10.5. Okay. You could plug 10.5 into the original statement, and it would give you a true statement. That would check out. Okay. Okay. Let me go ahead and throw in one. Okay. Example 3 looks like one where there is an extraneous solution. So let's do this one here. Example 3. Okay. It has square root of x plus 21. And then, okay, that's equal to 3 minus the root x. Okay. Now, there might be different ways to approach this. Let's see. What do you guys think would be a good first step?
Move the x equal.
I'm gonna maybe square both sides and see what happens. I think. Yeah, let's do it. Let's square both sides. Square, square. Okay. Now the right side. I guess right side isn't this something you have to FOIL? like the left side obviously would be x plus 21. But the right side, isn't this really, I'll rewrite this as 3 minus 3 root x times 3 minus 3 root x. Isn't that what 3 minus 3 root x being squared would look like? Okay, is that okay? And then you can go first, outside, inside, last. Okay. So x plus 21 equals 3 and 3 is 9. Outside, inside. Isn't this negative 3 root x and then another negative 3 root x that gives you negative 6 root x? And then negative root x, negative root x. Negative, negative makes a positive, and root makes just plain x. Is that okay so far? Okay. All right, now our goal is still to get x equals something at the end. What's a good next step? Subtract x. Oh, look at this. Ooh, that was pretty nice. Okay. Can I subtract 9 at the same time? Is that okay? Minus 9, minus 9. Okay. So on the left side, I'm getting, it says 12, I think. 12 equals negative 6 root x. Next step. Yeah, divide up negative 6.
Yep.
That's negative 2 equals root x. And last step is what?
Square.
Square both sides. Square.
4.
Yeah, I'm getting x is 4. Okay. Now, there are negatives flying around and square roots. So careful. I might suspect that. I wonder if this is extraneous. Let's check. Let's put 4 into the original statement. Guys, what's 4 plus 21? 5, or yeah, 25, and the square root of 25 is 5. Okay, so let's hold on to 5 over here. Okay. How about over here? What's the square root of 4? 2. And what's 3 minus 2?
1.
Would be 1. Guys, is 5 equal to 1? No. Now, maybe you could sort of get it to work if you consider the plus or minus version of the square root, but if you're not allowed to, which typically not, okay, then we're going to call this extraneous solution. Okay. So there really is no solution. Okay. Let me show you guys the graphical version of that, which is where I was going anyway. Okay. So if I go to Desmos and I plug these equations in, so I'll say y equals, say, square root of x plus 21, SQRT, and then x plus 21. Okay. And then separately from that, I'll do y equals, and then the right side was 3 minus root x. 3 minus SQRTX. Okay, that's those 2 equations, right? Okay. Now, if I back up and look at those graphs, okay. Guys, do those graphs ever cross anywhere? No, they don't. Okay, that's another way to say that there is no solution, right? Now, if you interpreted the square root as, again, like plus or minus, then wouldn't these be sideways parabolas? That would no longer be functions, they would be relations. And then in that case, I think they would cross right about here, which looks like which looks like around x equals 4. Hey, which is actually what got on paper too, isn't it? Right, but otherwise it's extraneous. Okay. So I want to do one more example with you guys, which is okay. Another way to solve equations is instead of an algebra process, you can use a graphing process. Ooh. So let's do this example of, I'm going to copy this straight out of the book. Here, I'll write it bigger. Okay. It goes 2 times the cube root of 3x minus 4. And then outside of the root, got a plus 10. Okay. And that's equal to 9. So how could you solve for x? Now, you could go through an algebra process. That's okay. Nothing wrong with that. Right? But they're prompting you to use a graph. So let's go over to Desmos, and I'll type this in. So clear this out, Right. And I'll do the same method I did before. I'll say y equals the left side and y equals the right side and just see where the graphs cross. And that would be the answer. So 2 times the cube root. Now, cube root, I'm going to use a power. So let's go 3x minus 4, and then just raise that to the power of 1 over 3. That'd be that. Boom, boom. Like that. All right, and then plus 10. All right, that was the left side of the equation. That's what that graph looks like, by the way. Haven't your cube roots been looking like this on Aleks? Your cube roots look like this funny looking S shapes. And then the right side of the equation said 9, so I'll say y equals 9. Right. And oh, guys, look where those cross. Now Desmos will give you a gray dot. You hover over the dot, tells you exactly the coordinate. So the solution is where x is about 1.29 and y is equal to 9. There you go. So you guys can solve graphically. Right, so, and that's a pretty complete overview of 6.6. Again, nothing super new. I don't think you couldn't have gotten out of Algebra 1. Okay, so, yeah, you guys are, I think, in pretty good shape to finish this lesson. I will walk around and help you guys out.